Hey, what's up guys? This is going to be video 2 of the kind of overview we learned from class the other day. This is going to be what we learned on Thursday and going all the way through to the graphs and the Venn diagrams. I'm going to occasionally pause on the to just kind of shoot the page so that you can pause, go back and look at the work and figure it out. So let's go ahead and dive right into it. So, looking at these right here, these are kind of like hidden sets. We don't know the value at all. So what we're going to have to do is we kind of have to decipher what's written in here. What the heck does this all mean? I mean, the first time I saw this, I had a heart attack. Let's go ahead and get into it. So we know that n is equal to natural numbers. Natural numbers are positive integers. It can be from 1 all the way to 100,000. It can be 1 to infinity as long as it's a positive whole number. So let's go ahead and write that. N equal to any positive whole number. Whole number, no decimals, no fractions, no mixed fractions. Just make sure that it is a positive whole number. So let's go ahead and decipher what's in set A. Okay, so this little symbol x through x means it's going to be one number all the way to another number. We'll just put x there for the unknown. So it's going to be one number all the way to another number. Now when it says en, and we can come back here to our handy dandy little things to memorize. And is a member of or is an element of. So when it says en, this means that all numbers will be natural numbers. Because they are members of natural numbers. That's what it says right here, is a member of or is an element of. So En is equal to all natural numbers, which are those positive integers. Okay, so we know that it's going to be x through x, and it's going to be all natural positive whole numbers. And then we come to this final line right here, and it's going to say that x is less than or equal to 100. Alrighty, so we know now that x is less than or equal to 100. Knowing all of this, we can begin to construct set A. So being that it's all positive numbers, it's a spectrum, and that it's less than or equal to 100, it can be any number from 1, we'll write 1, 2, 3, all the way to 100. That's because it's less than, or that's what this symbol means right here, less than or equal to 100, and they're all positive numbers. So now we have our set A. We know that it's all less than or equal to positive numbers. Let's try and figure out what set B means. So, set B, it's the same thing. It's a spectrum, just like we figured out right here. They're all going to be natural whole numbers from what we were able to figure out from our answer sheet. But this sign is flipped. So it's going to be greater than or equal to 100. So essentially that means that set B is going to pick up right where set A left off. It's any positive whole number that is greater than or equal to 100. So we got 100, 101, 102, goes all the way, and numbers don't stop. There's no stopping point. So it could be infinity, it could be anything from what we're able to decipher here. So there is no end to this to set B. Just goes on for a very long time. Now that we know our sets, now that we have both sets, we can start answering some problems. Let's come over here and look at the first problem, n parenthesis a. Kind of clean up, and again, sorry about the messy handwriting. Great, we have n parenthesis a. Well, what the heck does that mean? Let's come over here to our little answer sheet, and we can see that the number of unique items in a given set. And again, this is asking how many numbers are in set A. How many numbers are in set A? Let's go ahead and figure that out. So we come back up here, we'll write out our set A just so we can have it with us as we're doing the problem. 1, 2, 3, any number all the way to 100. That's our cap. Well, it's 1 through 100. How many numbers is that? And A is equal to 100. This is not a set because remember when we're asking how many numbers are in the set, the number itself isn't a set, it's just counting. So all numbers 1 through 100, what we're able to decipher from up here, that is our answer. There are 100 numbers inside of set A. Let's go ahead and move on to the next one here. We have n parenthesis b. We remember again, and this is asking how many numbers are in set B. How many numbers are in set B? We have our set B right up here, so let's go ahead and write it out so we have it with us when we're doing the problem. 100, 101, 102, and then it can go on to anything. From this right here, we know that there's no possible cap to it. So when it's asking NB, this is really hard. We don't have an answer. Or in math, we like to write does not exist. It does not exist because too many possibilities or too many numbers. I like that wording better. There are far too many possibilities that this could be. So we don't know how many numbers are in set B. So the answer to n parenthesis b, or how many numbers are in set B, does not exist. We don't know yet. We weren't given enough information in this top question here to be able to fill it out. Go ahead and get a shot of that page before I move on to the next one, so you're able to decipher and hit pause. Let's go ahead and move on to our next question. And again, I always like to, when I turn the page, like to write out the sets so that I have them with me. 1, 2, 3, 4, 5, all the way to 100. And set B, it's, remember, 100, 101, 102. It could be anything, and it goes on infinitely. We have no clue. Let's figure out this next question right here. A union B. So we gotta first figure out what is it asking. What is A union B? A union B will be put them together, but don't repeat elements. Or in this case, do not write the same number again. I'm gonna translate it here. Do not repeat numbers. Well, luckily for us, we have our sets right here, so let's go ahead and put the two sets together. So A union B is equal to 1, 2, 3, 4, goes all the way to 100. But here's the interesting thing. Since we're putting them together, we don't have, and we're not repeating numbers, we're not going to write 100 again. But we are, since we're putting them together, going to pick up right where set B leaves off, which is 101, 102, 103, and then it goes on and on and on. That's what happens when you put A and B together. You have the components of set A, which is 1 through 100, and then set B, which is 100 through infinity. Let's go ahead and move on to the next problem. We have A intersection B. What is this asking? Let's check out our answer sheet. This one is asking what numbers are in both. What numbers are in both sets A and set B? Well, let's come up here and take a look. We have 100 in set A, and we have 100 in set B. That's the only numbers that they share. So A intersection B is equal to 100. Boom. Able to get that pretty easy. Is in both sets A and B. Got that. Alrighty. Let's go ahead and, focus. There we go. Let's go ahead and move on to the next question. This is where it kind of starts to get a little tricky, but we can really decipher anything as long as we have our answer sheet right here, as long as we just kind of think critically on it. So the question is N parenthesis A union B. Now that we have that, let's find out what it's asking. So if you remember from algebra, you have to do everything in the parentheses first, and then you're going to do what's outside of the parentheses. So first, let's figure out what A union B is. Remember, we actually just did that problem right here, A union B, put them together, but don't repeat elements. So A union B was equal to that 1, 2, 3, 4. I gotta write that out. We already got that. Then it goes on to 100, 101, 102, and it just goes on and on and on and on. But we see here that it's asking for N. So N. Let's come back up here and figure out what that means. This is asking for, remember that N symbol means the numbers of unique items in a given set. Or again, how many numbers are in A union B? Well, we don't know. And again, we don't know because this right here goes on to infinity. So again, it's going to be that weird answer. Does not exist. Because too many possibilities. Sorry if I misspelled that, probably did. But yeah, that's right there. How many numbers are in A union B? We don't know because this right here can go on to infinity. Any number greater than 100. The answer does not exist. Let's go ahead and do that last one right there, which is N parenthesis A intersection B. Then again, according to our algebra rules, we have to do what's inside of the parentheses first before we can do anything else. Well, we actually just did A intersection B, which A intersection B is equal to, and we got it from up there, 100. So now that we have that, remember again, N is always asking how many numbers are in that set. So N of 100, I only see one number here, which is 100. So the answer is 1. Only one number in A intersection B. Because again, remember we did it up there. We figured out it was they only shared one number, which is 100. Same case down here. There's only one number that is shared by both. It is 100. Well, let me go ahead and get a shot of that page right there. Oh, actually, really quick to answer these two bottom questions. Are sets A and B well defined? Yes, they are well defined. Now I know that this bottom one goes on forever, but they are well defined because we're dealing with numbers. We're able to deal with objective topics. If it were not well defined, that would be a subjective topic. So numbers equal well defined, and subjective or opinions equal not well defined. Alrighty guys, that's it for this video. I'm going to go ahead and upload this one along with the other one. I'm going to do one more for the Venn diagrams. Thanks again.